Good day everyone, here we are at EE 323 Renewable Energy Sources. Our main goal for this video presentation is to discuss the solar-powered home, the grid tied. My name is Karen Joy B. SERAFICA as a hustler, Tom A. Castillo as a hacker, DEZYLYN G. MATEO as a hipster. So now, solar-powered home in terms of the three configuration, the grid tied, off-grid, and the hybrid. So grid tied yung gagamitin natin for today's discussion. So what is grid tied? A grid tied solar power system is connected to the home and to the traditional electricity utility grid. This type of solar power system does not include any storage battery. So yung grid tied daw, wala siyang storage battery. Next is the off-grid. This type is stand-alone system that is completely disconnected from the electric power grid. It contains a large set of battery packs which stores energy during the day to be used at night or at times when sunlight intensity is low. So yung off-grid naman, meron naman siyang battery kung saan pwede siyang mag-store ng energy during the day and night at pwede siyang gamitin kahit mahina yung source ng sunlight natin. And the last is the hybrid. A grid intertied solar power system is also connected to the traditional utility power grid which contains battery backup. The addition of battery backup enables the system to work when there is power interruption. So, itong hybrid, this is the combination of grid tied and the off-grid. So, magpo-focus lang muna tayo ngayon sa grid tied. Now, description naman ng grid tie. In a grid tie, the solar power system is being connected in parallel to the electric supply that goes inside the house and only function during the day. So, yung solar power system ay connected daw siya sa parallel and nagpa-function lang siya during the day dahil nga wala itong battery storage. Next, any excess energy that is being produced is then fed up into the grid. So, yung mga excess energy daw na napoproduce ay mapupunta sa ating grid. Since there is no battery backup, it does not produce power at night. And during brownout, the solar power system is also in a shutdown state, hence does not produce electricity. Next, its main purpose is to save electricity. In fact, when the solar array's rating matches the electricity consumption zero bill can attain, and when the solar array ratings exceeded the day and night electric consumption, the system will be able to produce excess power which will be paid by the distribution utility. So yung mga produce excess power ay maaaring bayaran ito sa atin ng mga distribution utility by means of consumption zero bill. So ito yung illustration or diagram ng three types of solar powered home: the grid tie, the off-grid, and the hybrid. So, tandaan, grid tie ang ating gagamitin for today's discussion. So now, this is the solar-powered home grid tie. Kung saan ito yung ating photovoltaic or the solar panel. Kung saan siya yung re-receive ng energy mula sa sun ay nagtatransmit ng electricity. So, ito yung mga ibang parts para makapag-generate ng electricity. The solar panel, the hosting load, the inverter, the utility interface, distribution panel, the AC switch gear, the watt-hour meter receiver and send, and last is the distribution line or the grid. So now, it shows that the excess energy is sent back to the grid. So yung mga excess energy daw ay nagsisend back yan sa ating grid. For example, there are 1,000 watts in solar array and the load is only 2,000. So the excess power we have is 1,000 watts, which it will be sent back to the grid. So in this scenario, your house is like a generator that's generating power towards the grid. But there is a condition. If the grid type setup is producing excess power outside, the power consumed is papatak sa ating kontador. Kahit papasok or papalabas ang power natin, magkakonsume pa rin ito ng metro sa ating kontador. In this rate, the solar power is now become useless. Kasi imbis na mapatipid ka, mapapagastos ka pa. So now, How to avoid this consumable excess power in solar panel. In the next previous slide, we will discuss how to install an effective solar-powered home. Solar-powered home grid type, the basic parts. So ito yung mga nilalaman ng magiging discussion natin. The solar panel, the grid tie inverter kung saan may with or without limiter, square wave or pure wave, the DC circuit breaker, the DC surge protection, the DC surge protection device SPD, AC circuit breaker, AC surge protection device SPD, time delay switch, DC or AC electrical wires, MC4 connectors, solar rail, and last is the clamps. So now, magsimula tayo ulit sa solar panel. So, di ba na-discuss na natin dati, ang solar panel is the one who collect the energy from the sun and transmit the energy to power electricity. In addition, solar power is the heart of the solar-powered home. Siyempre, kung walang solar panel, hindi tayo makakapag-generate ng electricity. So, the heart of solar-powered home, a typical solar cell will only produce around half of a volt. So, by connecting them together in series inside the panel, a more useful voltage is achieved. Most solar panels rated 150 watts or below are rated as 12 volts, while large solar panels are 24 volts. So, tandaan yung mga small solar panels natin ay nagre-rate siya ng 150 watts or below rated as 12 volts. Pag malalaking solar panel naman, nagre-rated siya ng 24 volts. A 12-volt solar panel produces around 14 to 18 volts when put under the load. This allows a single solar panel to charge up a 12-volt battery. Incidentally, if you connect a voltmeter up to a solar panel and it's not under load, you may well see voltage readings up to 26 volts. This is normal in an open circuit on a solar panel. As soon as you connect the solar panel into a circuit, this voltage level drops to around 14 to 18 volts. So now, pumunta naman tayo sa solar panel connection. Solar panel can be together to create a solar array. The output of a solar array is computed much like a battery. So, ano bang merong connection tayo sa ating solar? Diba? Nag-a-act ito bilang isang DC or direct current. So, sinasabi dito, it is like a battery. So, yung solar panel connection natin, meron tayong 3 types. The series connection, the parallel connection, and the series parallel connection. So, first, series connection increases the voltage while the current remains the same. Sabi dito, increases the voltage, the current remains. The formula is current total is equal to I1 is equal to I2 is equal to I3. Currents in series connection are all equal. Voltages naman, V1 is equal to V2 plus V3, sum of voltages of all solar panel. Our output naman or the power is equal to volts times ampere. Output voltage multiplied by volts times the current. Next connection naman natin is the parallel connection. Increases the current while the voltage remains the same. So, yung current naman dito yung tumataas and the voltage remains. So, current total is equal to I1 plus I2 plus I3, sum of currents of solar panels. Next is voltage. Voltage total or the total voltage is equal to V1 is equal to V3. Voltage in part connection are all equal. And same lang din siya ng pag-compute ng output voltage. Multiply by volts and current. So this is the multiple panels or the series parallel connection. The power of the overall system is increases regardless of whether they are connected in series or parallel. So let's take a recap of the formulas that we will use later. The series connection, the parallel connection, current. The current remains the same while increasing the voltage. Sa parallel connection, increasing the current while the voltage remains the same. So now, let's compute. Each panel on the next slide is rated at 12 volts and 10 ampere. Calculate the following. So, isolve muna natin yung series and the parallel. So, sa series, ang mag-i-increase dito yung voltages na lang natin. Dito naman sa parallel, ang mag-i-increase is the current. So, ang magiging sagot natin sa series connection, the current remain the same, which is equal to 10 ampere. The voltage total is equal to 36 volts. So, ang magiging power output neto is equal to 360 watts. Sa parallel connection naman, voltages remains the same, which is equal to 12, and the current, increasing the current, is equal to 30 ampere. And the total output power is equal to 360 watts. Now, dito naman tayo sa ating 4 panels in terms pa rin ng parallel and series connection. So, ang magiging sagot natin dito ay voltage is equal to 24 volts, total current is equal to 20 amperes. So, ang magiging power output natin is equal siya sa 480 watts. Ganon din sa ating series connection with 4 panels, 24 volts, the voltage total. The total current naman is equal to 20 ampere and the power output is equal to 480 watts. Remember that it is not advisable to connect different output voltages in different kind of connection. The connection must be connected in series connection and or in parallel connection to have the same value of voltages. So, in installing solar panel, don't use odd numbers of the solar. Dahil kung magsi-series or parallel ka, hindi mo magagamit yung odd numbers. Dapat maging 2 on 2 to, 3 or 3, 4 or 4, or so on and so forth. Next is the solar panel types, the polycrystalline and the monocrystalline. So kung titingnan natin ang appearance ng dalawa, ang pagkakaiba lang nito is yung kulay. Ang polycrystalline ay kulay blue, ang monocrystalline ay black. So para mas maintindihan pa natin ang pagkakaiba ng dalawa, ito yung table nila. Factors in terms of silicon arrangement. Sa monocrystalline, meron tayong one pure silicon crystal, and sa polycrystalline, meron tayong many silicon fragments melted together. So dito, puro yung silicon crystal. Dito naman, melted na maraming silicon fragments. Next naman, in terms of cost, mas mahal yung monocrystalline at mas mura naman sa polycrystalline. In terms naman sa appearance, panels have black hue, sa polycrystalline naman, blue hue naman. So, yun yung sinabi ko kanina, yung kulay blue at kulay black. So, in terms naman sa efficiency, more efficient sa monocrystalline, less efficient sa polycrystalline. So, in terms naman sa tagal or lifespan, 25 to 40 years sa monocrystalline, and polycrystalline naman, 20 to 35 years. So, temperature coefficient, sa monocrystalline, meron tayong lower temperature coefficient, making them more efficient in heat. So, next naman sa polycrystalline, higher temperature coefficient, making them less efficient in heat. So, kung ako yung pipiliin, doon tayo sa mahal na kailangan ng lower temperature coefficient. Pero, sa pag-i-install kasi ng solar panel, depende yan sa nagmamayari or yung magpapagawa ng solar-powered home. Next naman natin ay inverter. From ordinary or most common use na binibili ng mga taong inverter ito. And para sa mga mahal na brands naman, ito yung mga ginagamit nila kung saan patitignan mo parang mahal talaga. So, di ba, as an electrical engineering student, alam natin ang inverter ay nagko-connect yan ng DC to AC. So, paano nga ba to ginagamit sa ating solar panel naman? So, kung natatandaan nyo, sinabi natin kanina, yung solar panel natin, nag-a-act siya like a battery. So, ang connection nito ay DC. Ang mga appliances natin ay connected yan in AC. Now, inverter converts the DC output of the solar panel into AC, which is the standard used by all commercial household appliances. So, di ba yung mga standard appliance natin ay AC. Hence, the inverter output matches the voltage within the house that is coming from the grid. Traditionally, there is usually one central inverter in a solar system. One more recent invention has been the microinverter. Microinverters are connected to individual solar panels so that each individual panels provide a high voltage alternating current. So, ano nga ba itong microinverters? So, ang microinverters, yun yung pagkoconnect ng inverter sa bawat solar para mag-provide ng high voltage alternating current. This setup are typically used only with the grid tie system and are not suitable for system with battery backup. So itong microconverter daw ay sa pang grid tie lang siya at hindi siya pa pwede sa for grid tie system, though costly. They do offer some traditional central inverter. So note, a grid tie inverter unique characteristic over the other type is it automatically shut down the system when there is a power interruption. So ang main function ng ating grid tie inverter, siya yung mag-automatic shutdown ng system natin pag nagkaroon ng power interruption. So ngayon, pumunta naman tayo sa two types ng grid tie inverter, the pure sine wave and the modified sine wave. So first is the pure sine wave inverter. This type, output voltage in the form of sine wave. Utilities also provide sine wave output. Because of this, pure sine wave inverters are usually needed if you are going to be tied to the grid. Typically, you need the pure sine wave inverter for sensitive equipment, newer TV, CFL light bulbs, and appliances with AC motors, microwaves, and refrigerators. So, pure sine wave inverters are capable of producing cleaner, smoother, quieter, and more reliable electricity to operate appliances and electronics without interference. Renogy sells a range of pure sine wave inverters of varying capacity, your solar installation, and your energy needs. So, itong pure sine wave daw ay mas nagpo-produce ng tahimik at malinis na system kung saan wala kang maririnig na humming sa iyong appliances. Next naman natin is the modified sine wave. In pure sine wave inverters, the AC power produced by the inverter very closely matches on the actual sine wave. In modified sine wave inverters, the polarity abruptly switches from the positive to negative when looking at the wave. It has a stair-step square pattern where the polarity is flipped back and forth. The choppy wave can negatively affect more delicate sensitive equipment. If you have a medical equipment you need to power such as CPAP or CPAP machine, you won't able to use modified sine wave inverter. Additionally, in many cases, you will hear hum with the devices attached to a modified sine wave inverter. The only advantages of this type of the pure sine wave is that it is much cheaper. So may mga negative effect din tong modified sine wave kung saan makakaroon ka ng mga hum sa device. Pero sa modified sine wave, dito ka mas makakatipid dahil mas mura ito. So this is the modified sine wave and the pure sine wave kung saan dito kung mapapansin nyo, pa-square ito and ito pure lang, pure wave. So dito sa modified sine wave, kaya may pa-square yan dahil sa ating ripple factor kung saan ito yung cause ng hum or humming. Dito naman sa pure sine wave, di ba sabi kanina is smoother and clear, wala kang maririnig na hum.
Next is the DC circuit breaker. The DC circuit breaker, sometimes referred to as the PV disconnects, are placed between the solar panels and the inverter, or in many cases built into the inverter. Just like a typical CV, it acts as an overcurrent protective device. Short circuit on the part of solar array may produce high value of current which might damage the inverter or the system, as the whole circuit breaker acts as an automatic switch, disconnecting the inverter from the solar array. It may also serve as a manual switch if there is a need to turn the solar power system off or isolate the solar panel from the rest of the system. So yung DC circuit breaker, it acts as an overprotective device. For example, yung appliance kaya lang i-tolerate ay 20 amperes, tapos may biglang pumasok na 40 amperes na kuryente. The function of the breaker is magtitrip siya para yung 40 amperes ay di makapasok sa appliance bago niya ma-damage yung electronic device na pinoprotektahan. So, magtitrip na siya. Next is the AC circuit breaker na RCBO type. So, ito yung gagamitin natin. Magkaiba ang DC circuit breaker sa AC circuit breaker na RCBO type kasi itong DC circuit breaker na MCB, may polarity siya. Tapos sa AC circuit naman na RCBO is yung symbol niya may sine wave na nakalagay. So ano ba yung pinagkaiba ng RCBO type? The AC circuit breaker are placed after the inverter. Just like a typical CB, it acts as an overcurrent protective device due to short circuit and overloading. So yung cause kaya nagkakaroon ng overcurrent ay due to short circuit and overloading. RCBO stands for Residual Current Operated Circuit Breaker with Overcurrent Protection. In the RCBO type, it has added protection since it can sense earth leakage current where the typical breaker cannot. It has the capability to trip when somebody touches a live wire, thus protecting the people around you. It also serves as a manual switch if there is a need to turn the solar power system off. So may pinagkaiba ang RCBO sa MCB katulad ng kanina sa DC kasi ang MCB can provide protection against overcurrent and short circuit only, while RCBO can provide protection against overcurrent, short circuit, and earth leakage current. So ano ba yung earth leakage current? It is the unwanted, unused waste current flowing from a live conductor or terminal to the ground or earth through the ground conductor or any other conductive path. Earth leakage with a high current mostly occurs in electrical transmission lines, can be called earth fault. It also occurs in transformer and other electrical devices. Earth leakage current flow to the ground conductors to the earth. If there is no grounding or earth system is available or improper grounding, then the earth leakage current will try to flow through any other conductor path. Example dito is yung human body. Although it is not possible to make an electrical insulation with 100% no leakage, but it should not be cross the limit. Next, the surge protection device na direct current. The DC SPD are placed parallel to the DC circuit breaker. SPD generally protects the system from power surge or more appropriately called voltage transients. SPD redirect this excess power to the ground. In PV system, since solar panels are transient voltage is primarily caused by lighting either directly or indirectly, multiple interconnection with the power cables is very susceptible to electromagnetically induced transients, where power surge could also arise. Transient voltage is the occurrence of very high voltage in a very short duration of time, around tens to hundreds of microseconds. Exposure to this transient voltage may cause a catastrophic component damage leading to system failure. So yung surge protection device, pinoprotektahan niya yung system against the transient voltage. So ano ba yung transient voltage? Transient voltage are caused by the sudden release of stored energy due to incidents such as lightning strikes, unfiltered electrical equipment, contact bounce, arcing, capacitor bank, or generators being switched on and off. So kung mayroong DC, meron ding AC surge protection device. So ano ba pinagkaiba ng AC sa DC surge protection device? So the AC SPD are placed parallel to the AC CB. Just like DC SPD, this serves as protection against transient voltage, but this time on the AC side of the PV system, SPD redirects this excess power to the ground. Multiple equipment connections on the grid, either internal or external, can also be a cause of electrical anomalies where power surge could also arise. Next is the time delay switch. This can also be called as power on delay. It delays the turning on of any electronic device for a desired time interval. This device serves its useful purpose usually when brownout occurs. After a brownout, when power have already been restored, there is the tendency of power surge which may damage the system it's being turned on right away. To prevent this, time delay switch delays the turning on of the system for a minute or even a bit more. So yung time delay switch na tinatawag ding power on delay will delay the electrical connections for like a minute until the power stabilizes. By doing so, your electronic devices is protected from the expected post-brownout voltage surge, which in turn ensures the continuous safety and performance of your electronic devices or appliance. Next is the programmable timer switch. Turning the solar power system on and off will be a vital routine which cannot be perfectly done in a day basis. Programmable timer is a hassle-free switch that automatically turn the system on and off the desired time. So yung programmable timer switch is a device that controls exactly when an electronic device or like solar panel is to be switched on and off. The next is the net metering. So what is net metering? Net metering allows customers of distribution utilities to install an on-site renewable energy facility not exceeding 100 kilowatts in capacity so they can generate electricity from their own use. Any electricity generated that is not consumed by the customer is automatically exported to the DU's distribution system. The DU then gives peso credit for the excess electricity received equivalent to the DU's blended generation cost, excluding other generation adjustment, and deducts the credits earned of the customer's electric bill. Is net metering already available in the Philippines? On May 27, 2013, the Energy Regulatory Commission adopted ERC Resolution 9 Series of 2013 approving the rules enabling the net metering program for renewable energy. This resolution was published on July 10, 2013 in newspapers of general circulations in the county and took effect 15 days thereafter. Thus, the net metering rules took effect in the Philippines on July 24, 2013. The net metering program is available only to on-grid distribution system or these connected to the transmission grid. What benefit will I get if go into net metering? By generating electricity for own use, you reduce the amount of electricity you buy from your local DU. The rating of savings or avoided costs realized on electricity generated for own use equivalent to the DU's retail rate consisting of charge for generation, transmission, system loss, distribution, subsidies, taxes, and other charges. You also earn peso credits on any excess electricity exported to the DU equivalents to the DU's blended generation cost, excluding other generation adjustment. The peso credits earned is then used to reduce your electric bills. How will my DU meter may import and export energy? The DU may opt to install two unidirectional meters, one to meter energy you buy from your local DU, and the other to meter the energy you export to the DU. The DU may at its options install a single bidirectional meter that can meter both import and export energy if find it to be more economical. The DU may also install a third meter in proximity to your RT facility to meter its total RT generation. The total RT generation shall earn for the OS-DU RT certificates which the DU can use to comply with its Renewable Portfolio Standards obligations. Who are qualified to participate on the net metering program? DU customers who are in good credit standings in the payment of their electric bills to their DU are qualified to participate in the net metering program for renewable energy. These customers are referred to in the Rules of Qualified End Users or QE. So what is the consequence of not applying for net metering? In the case that solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. Example is when the system is rated at 5 kilowatt and the load consumption is only 4 kilowatt. The system will have an excess of 1 kilowatt which will be sent to the grid. This excess energy will pass through the meter, hence will be billed to the owner. Another question is there any other way beside net metering that a customer having a solar power system producing excess energy during the day and yet will not pay for it? The answer is yes. This can be achieved by using an inverter with limits. This device limits the power that the system will dissipate. It automatically detects the maximum power that the system can provide without the excess being sent to the grid.
Now, let's proceed to circuit connection. So, this is how solar-powered connection works. So first, we will connect our solar panel to DC junction box, then connect to DC isolator. After that DC isolator will be connected to string inverter, then to solar power meter, and now we will connect it to AC circuit breaker that will be connected to our consumer junction box to power up the house or give load. After that, our consumer junction box will connect to net metering and to grid if our solar panels didn't produce electricity. We'll get it from the grid. Next is the wire sizing. The first wire is TW, or the thermoplastic wire, which has moisture resistant and flame retardant. Next is THW, or thermoplastic heat wire, which is heat resistance wire and also moisture resistant and flame retardant. And the next wire is THHN, which is high heat resistance, designed for a specific insulation material, temperature rating, condition of use, suitable for dry and damp locations. And the last one is THHN/THWN2. The THWN is rated up to 75 degrees Celsius, while THWN is up to 90 degrees Celsius. So, the W in their acronym means water resistance. So, these are the combined capabilities of THHN/THWN2 design. So, we have here a note. Here is a breakdown to help make some sense of the lettering. So, I stands for thermoplastic insulated cable. And single H means the wire is heat resistant, and double H means that the wire is heat resistant and can withstand a higher temperature. The added W single signifies that the wire is also resistant to water. Now, let's proceed to PV wires. This kind of wire is created for PV applications, and also these cables extremely behave in very hot temperature and other harsh environmental conditions. The special characteristic of it is its insulation compared to other wire, which is made up of XLPE or EPR. XLPE is an acronym for a cross-linked polyethylene, and EPR means ethylene propylene rubber. These are the PV wires. Also, these are the sizes in American wire gauge or AWG. Let's proceed to the table that we can use in wire sizing. So this table is ampacities of insulated conductors. Next is the magnified view, which starts at 14. This table is the correction due to ambient temperature. There is also ambient temperature adjustment for raceways or cables exposed to sunlight on or above rooftops. Furthermore, we have adjustment factors for more than 3 current-carrying conductors. So, this is the American wire gauge cross-sectional area in centimeter. These are the steps in PV system conductor sizing. First, look for the ISC rating of PV cell. Next is multiply by 2 safety factors, irradiance and continuous duty. Next is refer on the table 310.15 B16 for the size of wire. Next is refer on the table 310.15 B2A for ampacity correction due to ambient temperature more than 30 degrees Celsius. Next is refer on the table 310.15 B13C to ambient temperature adjustment due to conduct or wire distance from the roof. Next is refer on the table 310.15 B3A for adjustment due to more than 3 wires inside a conduit. Next is find the adjustment due to voltage drop. And the last step is the value obtained. In the last step will be the basis for the size of wire to be used in the PV system. These are the example of PV cell specs. We have Jinko Solar, Jazz Solar, Suntech, and 3 na solar, that we can see the different spec of each.
So ito yung sample in PV system conductor sizing. Find the proper wire size for a grid-tied PV system consisting of 3 GA solar panels connected in series with specs at the previous lines. So, ang susundin natin specs ay yung GA solar panel. So ito yung specs na pagbabasihan natin. So doon na tayo sa may step 1. Step 1, look for the ISC rating of PV cell. So base sa specs dito, ang ISC is 9.75 amperes. So ang current natin is 9.75 amperes. Siya yung IPV. So doon na tayo sa main next step. Ang next step is multiply by 2 factors. Ito yung irradiance and continuous duty. So bali current natin, which is 9.75 times natin sa 1.25 times 1.25. So ang IPV new natin is 15.23 amperes. So, ito na yung new current na mag-generate. So, doon na tayo sa step 3. Refer on table 310.15B16 for the size of the wire. So, mamimili na tayo ng wire na gagamitin natin. So, ano ba yung magandang wire? So, ito yun. Kasi nandito yung THWN2, nandito rin yung THHN. So, ngayon, pagkari natin mamili, titingnan natin yung size ng wire. So, ito yung napili natin. Ngayon, pagbabasihan natin yung current rating. So, ano ba yung current natin? Ang current natin is 15.23 amperes. So, base dito, ano yung pinakamalapit sa 15.23 amperes? So, dito, ang pinakamalapit sa 15.23 amperes is 25. So, bali, ang magiging size natin is 14. The table indicates number 14 THHN with ampacity of 25 amperes. So since number 14 EWG is not the best practice for PV system, kailangan natin tabaan yung wire natin. So ano ba yung kasunod ng number 14? So ang kasunod na number 14 is 12. So bali ang magiging ampacity na natin is 30. Kaya ang sabi dito, use number 12 THHN with an ampacity of 30 amperes. So ano ba yung ampacity? Yung ampacity, ito yung current na kaya niyang dalhin. So, pag lumagpas sa 30 amperes, masusunog yung wire. So, ngayon, dito na tayo sa main step 4. Opacity correction due to ambient temperature. So, kanina yung opacity natin na 30 amperes, ay nakabase siya sa 30 degrees Celsius. So, since Philippines ambient temperature is around 37 degrees Celsius, is magkakaroon tayo ng new wire opacity. So, ano ba yung multiplier natin para malaman natin yung new wire opacity? So, since Philippine ambient temperature is around 37 degrees Celsius, so, saan ba siya pasok? So, dito siya sa 36 to 40 degrees Celsius. So, yung wire na pinili natin kanina is 90 degrees Celsius. So, dito tayo pipili. Since pasok yung 37 degrees Celsius dito sa 36 to 40 degrees Celsius, ang magiging multiplier natin is 0.91. So, yung 30 amperes na capacity natin kanina, ito times natin siya sa 0.91. So, bali 27 amperes yung new wire capacity natin. So, step 5, ambient temperature adjustment due to roof wire distance. So, hindi naman natin ilalagay yung solar panel natin sa loob, kundi sa may bubong. Dahil mas mataas yung temperature sa bubong. Kaya magkakaroon tayo ng new ambient temperature. So, yung solar panel natin is ilalagay natin sa above the roof. Kaya yung temperature other natin is 22 degrees Celsius. So, 1/2 inch above the roof. So, yung 37 degrees Celsius na ambient temperature natin, ipa-plus natin yung temperature other natin na 22 degrees Celsius. So, magiging new ambient temperature natin is 59 degrees Celsius. So, dahil nabago yung ambient temperature, mababago rin yung capacity natin. So, ngayon dahil 59 degrees Celsius na yung ambient temperature natin, mababago na yung multiplier natin. So, dito, saan ba pasok yung 59 degrees Celsius? So, dito siya pasok sa 56 to 60 degrees Celsius. So, katulad niya kanina, dahil yung wire natin is 90 degrees Celsius, so, dito tayo mamimili. So, yung 56 to 60 degrees Celsius, ang magiging multiplier natin is 0.71. So, yung capacity natin na 27 amperes, ito times natin siya sa 0.71. So, bali ang magiging final wire ampacity natin is 19.17 amperes. So, since 19.71 amperes is greater than 15.23 amperes na original maximum current natin, our selected number 12 wire will fit the system. So, dito tayo sa step 6. Ito yung adjustment due to more than 3 wires inside the conduit. Since there's only 2 wires inside the conduit, this step can now be passed by. So, move na tayo sa step 7. Ito yung adjustment due to voltage drop. So, dapat yung voltage drop natin is less than 3%. So, paano ba natin malalaman na less than 3% o hindi yung voltage drop? So, ito yung formula natin. Voltage drop is equals to 2IR. So, yung I is yung current and yung R yung resistance. And yung R is equals to K times length divided by area. So, ano ba yung I natin? So, base sa specification natin, ang maximum power current is 9.30 amperes. Kaya tinimes siya sa 9.3. So, ngayon dahil yung R natin is equals to K times length divided by area, isa-substitute na natin yung R natin. So, yung K natin is 12.9. So, ito times natin sa length. So, yung length natin is 25 feet. So, ngayon yung area natin. So, paano natin nalalaman yung area natin? So, dahil ang size ng wire natin is 12, ang area natin is 6,530. So, ngayon, pagka natin kunin yung area, makukompute na natin yung voltage drop. So, ang naging voltage drop natin is 0.92 volts. So, ngayon, paano natin malalaman yung percent ng voltage drop? So, yung 92.92 volts na voltage drop natin, i-divide natin sa maximum power voltage, then times 100%. So, ano ba yung maximum power voltage natin? So, based on the specs, yung maximum power voltage is 32.26 volts. So, 0.92 divided by 32.26 times 100%, ang percent ng voltage drop natin is 2.85%. Since 2.85% is less than 3%, our selected number 12 wire will fit the system. But, since 2.85 is a bit near to 3, it will be better to use number 10 THHN wire for additional safety factor and for future expansion. So, on the previous problem, in case daw na yung voltage drop is greater than 3%, katulad nga dito sinabi is 5%, yung pinili natin na wire na number 12 THHN, make a one-step higher adjustment. So, select initially number 10 THHN. So, ngayon, dahil nga binago natin yung size ng wire natin, mababago rin yung area. So, ano ba yung area natin ngayon? So, dahil 10 na yung size ng wire natin, ang area natin is magiging 10,380. Kaya, ang magiging voltage drop natin is 0.058 volts. Ang magiging percent ng voltage drop natin is 0.18%, which is less than sa percent ng voltage drop kapag ginamit natin yung number 12, which is 2.85%. So, select number 10 THHN as the final wire to be used in the system. Kasi nga, mas less siya sa 2.85% na malapit sa 3%, kaya mas safe siyang gamitin. And pwede ko pa magdagdag.
This is a sample problem in PV system conductor sizing, but also through table, we can find the answer. So we have here the different sample wire size chart of PV system. Also, this one is for 12 volts renewable energy system keeping voltage loss under 5%. While this one is for 24 voltage renewable energy system. Now, let's proceed to circuit breaking sizing. So, we can see here the table 240.6A, A standard ampere ratings for fuses and inverse time. So, these are the example of standard ampere ratings. Now, let's proceed to DC circuit breaker sizing. First thing to consider in sizing ACB for PV system is the ruling in PEC which states that PV circuit current is continuous. Thereby, the minimum OCPD rating is 125% of the maximum current. PEC 2017 Article 6.90.2.2b and Article 6.90.2.3b. Therefore, in reference to the problem in conductor for sizing, on the DC use side, the max current is 15.23 ampere multiplied by 125%, that is 19.04. Use 25 ACP. On the AC side, let's assume that the inverter rating is 1.5 kilowatts and a current of 12 ampere. Multiply by 125%, that is 15. Use 20A CB or RCBO.
Next part is the surge protection device or the SPD sizing. So, SPD sizing. The rule is simple in sizing of surge protection device. Basically, the UCF rating of the SPD should match the system voltage or a bit higher, 15 to 25% for SPD to attain any longer lifespan. So, sinasabi dito yung SPD sizing ay kailangan mag-match sa ating voltages with 15% to 25%. Therefore, in reference to the problem conductor sizing, para sa ating DC side, use SPD-UC rating up to 100 to 120 volts. Sa AC side naman, use SPD with UC rating of 230 to 275 volts. So ito yung picture ng ating SPD direct current. So malabo yung picture natin dito. Pero dito nakikita yung UC. Ito, makikita natin yung UC dito. So kung mapapansin nyo sa ating direct current, meron siyang positive-negative charges kung saan makikita nyo yung polarity. Ito naman yung picture ng ating alternating current. So kung mapapansin nyo, wala siyang polarity. Ang makikita niya is L, 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 LN, so and so forth. So yun yung pagkakaiba ng alternating current saka DC current SPD. Sa ating DC, makikita mo yung polarity. Dito naman ay hindi. So, punta naman tayo sa SPD specs. IN stands for nominal discharge current, IMAX, maximum discharge current, UC, maximum continuous operating voltage or MCOV. So ito yung tinitingnan natin sa ating SPD. Sa next is UP, voltage protection rating or BVR, or surge voltage rating SVR or clamping voltage. So now, ang next part naman natin is zero bill computation. So kung mapapansin nyo, ito yung kilowatt hour per day natin. So yung red nagsisimbolize ng 7, yung medyo yellow is 6 to 6.5. So how to compute for your monthly average kilowatt use? So halimbawa meron tayong 300 kilowatt hour, convert mo siya sa daily usage, 300 kilowatt hour mo divided by 30 days. So kung meron kang 10,000 kilowatt per day, ang magiging equivalent in watt hour per day is equal to 10,000. So note, in PH, peak sun hours is equivalent to 5 hours per day. So for solar array rating, 10,000 divided by 5 is equal to 2,000. So sagaling itong 5 dito sa ating peak sun hours. Zero bill assurance, 2,000 watts times 1.1 is equal to 2.1 watts. So yung number of panels na kakailanganin mo, 2,200 watts divide mo sa 300 is equal to 7.33. Or i-range na natin siya ng 8 solar panel. Solar panel installation tayo. Best location to install solar panel. So, according to research, south is the best location to install solar panel. And why? Solar panels are typically installed in a fixed manner on the roof of your house and should be facing south, which receives the most sunlight. Solar panels generate more electricity when they get the most sunlight, which comes from the southern direction. So, sinasabi nga dito, ang most sunlight direction is the south. So para makakuha ka ng maraming sunlight, itatapat mo siya or i-angle mo siya sa southern direction. So that's all for today. Thank you for listening. God bless.